Hello everyone. Today I am here to discuss a subtopic of arithmetic progression where I'll be discussing about sum of first n terms of AP and we'll be discussing the problems based on sum of first n terms of AP. So let's start with the topic now. So sum of first n terms of AP. What do we understand from sum of first n terms of AP? So in this case, the sum of first n terms of AP is denoted by Sn, and here if we'll take let A1, A2, A3, A4 and so on up to An are in AP, then Sn will be A1 plus A2 plus A3 plus A4 and so on up to An. Now we will try to find out the formula by which we can find the sum of first n terms of AP. So as we know, the first term A1 we generally denote it by A and the common difference as D. So if we'll take the first term, it will be A. Second term, it will be A plus D. Third term, it will be A plus 2D and so on. If you'll take a n minus 1th term, it will be a plus n minus 2d, and nth term will be a plus n minus 1 into d. Now as we know that addition is commutative, if we'll rewrite the sum of first n terms of AP in the reversed order, we will get a plus n minus 1 into d plus a plus n minus 2 into d plus and so on. The second last term will become a plus d and the last term will be a. Now on adding the corresponding terms of these APs, we'll get Sn and Sn, that will be 2 times Sn. Now if you'll add here the first term a and a plus n minus 1 into d, what we'll be getting is, we'll be getting 2a plus n minus 1 into d. Further, when we add a plus d and a plus n minus 1 into d, we will again get 2a plus n minus 1 into d. And this way, if we'll add a plus n minus 2 into d and a plus d, we will get 2a plus n minus 1 into d and a plus n minus 1 into d and a will give 2a plus n minus 1 into d. So this sum will come n times. That means we can write it as n into 2a plus n minus 1 into d, which can be written as Sn equals to n by 2 into 2a plus n minus 1 into d, which will be n by 2 into a plus n minus 1 into d. And as we know, here a plus n minus 1 into d is the nth term. So we can also write it as n by 2 into a plus an, or we can also write it as n by 2 into a plus l, because l is also known as the last term or nth term. So we have two formula to find sum of n terms of AP, that is Sn equals to n by 2 into 2a plus n minus 1 into d, and also we have n by 2 into a plus an. Now it depends on what values are given. Based on that, we'll be using the formula. If a and d is given, we'll be using the first one. And if we know the first term and the last term, we'll be using the second formula. But if any confusion is there, you can always go ahead with the first one and solve the question. Now coming to some of the important points related to sum of n terms of AP. So if we'll talk about the first point, that is if A1, A2, A3 and so on, an minus 1 and an are in AP, then we can write A1 plus AN will be equals to A2 plus AN minus 1 will be equals to A3 plus AN minus 2 and so on. That means in the sequence of AP, the sum of the term equidistant from the beginning and end is always equal. Second point, if Sn is An square plus Bn, then the sequence is in AP. That means if we have Sn as a quadratic polynomial without constant, then when you find out the terms of that sequence, you will get the sequence as an AP. Third point is, we know S1 is A1. If you'll take S2, this will be A1 plus A2, which can be written as S1 plus A2. So from here, A2 will be equals to S2 minus S1. S3 will be A1 plus A2 plus A3, which can be written as S2 plus A3, as A1 plus A2 is S2. And from here we can write A3 as S3 minus S2. S4 will be this way. We can write it as S3 plus A4, and so A4 will be equals to S4 minus S3. If this pattern will follow, we'll get An equals to Sn minus S of n minus 1. So this is another formula to find An when Sn is given. Otherwise, normally when Sn is given, we'll follow this sequence in order to obtain the terms, and following which we'll try to find out the common difference to generate the arithmetic progression sequence. Let's move to the question now. The first question here is find the sum of the AP 2, 7, 12 and so on up to 10 terms. So in this case, we have A equals to 2, D is 7 minus 2, which will be 5, and N is 10. We have to find S10. So we know that Sn equals to n by 2 into 2a plus n minus 1 into d. On substituting the value of n, we'll get S10 equals to 10 upon 2, 2 into 2 plus 10 minus 1 into 5, which will be 5 into 4 plus 10 minus 1 is 9, 9 into 5, 45. We'll get 5 into 49, which will be 245. So next question is find the sum of 34, 32, 30 and so on up to 10. So here the first term is 34. The common difference is 32 minus 34, that is minus 2. Nth term is 10. So first of all, we'll try to find out the value of n here because it depends on n. So we'll take An equals to 10, and Anth formula is A plus n minus 1 into d, which is 10. The value of A is 34 plus n minus 1 into minus 2 is equals to 10, which will be 34 minus 2n plus 2 equals to 10. Further, we can write it as 36 minus 2n equals to 10. So we'll get 2n equals to 36 minus 10, that will be 26. And so n will be equals to 13. Now here, as we know n, a and d, we can use either the first formula, that is n by 2 into 2a plus n minus 1 into d to find out the sum, or we can use n by 2 into first term plus last term. So here Sn will be equals to, we'll take n by 2 into a plus an, n is 13, so that is 13 upon 2 into first term is 34 and the last term is 10, which will be 13 upon 2 into 44, which will write it as 13 into 22, and that will get it as 286. The next question is, how many terms of the AP 9, 17, 25 must be taken to give a sum of 636? So here we know A is 9, the value of D is 17 minus 9, which is 8. The value of Sn is 636. We have to find n value. So here we will take Sn equals to 636. Sn equals to n by 2 into 2a plus n minus 1 into d, which is 636. N value we have to find, so it will be n by 2, 2a. A is 9, it will become 2 into 9, 18 plus n minus 1, common difference is 8, which is 636. We can write it as n by 2 into 18 plus 8n minus 8 equals to 636. Now here n by 2 into 18 minus 8, that will be 10 plus 8n equals to 636. On taking 2 common, we'll get it as n into 5 plus 4n equals to 636. On expanding, we'll get 5n plus 4n square equals to 636. We are going to write it in the quadratic form here. 4n square plus 5n minus 636 will be equals to 0. Now we will solve it by factorization method. So by using the factorization concept and splitting 5n with the help of 4 and 636, we will get 4n square minus 48n plus 53n minus 636, which will be 0. We'll take 4n common, that will be n minus 12 plus 53 common, will be n minus 12 equals to 0. Further, we can write it as n minus 12 into 4n plus 53 equals to 0. That means n minus 12 will be 0 or 4n plus 53 will be equals to 0. That means from here n will be equals to 12, or from here n will be minus 53 upon 4, which is rejected as the term cannot be negative or fraction. So therefore the value of n will be 12. So that means there will be total 12 terms to get the sum 636. The next question is, the first and the last term of AP are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? So here the first term, that is A, is given 17, and the last term, that means nth term, is given 350. So using that nth term formula, we will try to find out n value as the common difference is given as 9. So an is a plus n minus 1 into d, which is 350. The value of a is 17 plus n minus 1, common difference is 9, which is 350. We can write it as 17 plus 9n minus 9 equals to 350. It will be 9n plus 8 will be equals to 350. Further, we can write 9n equals to 350 minus 8, which is 342. And so the value of n will become 342 upon 9, which will be 38. Now, as we have got the number of terms, we will find their sum. So now Sn, here we'll use the formula n by 2 into a plus an, as we know the first and last term. So it will be 38 upon 2. First term is 17 and the last term is 350, which we can write it as 19 into 367. The value of it will be 6,973. The next question is, if the sum of first 7 terms of AP is 49 and that of 17 terms is 289, find the sum of first n terms. So it is given the sum of first 7 terms, that is S7 is 49, which we can write it as 7 by 2 into 2a plus 7 minus 1, that will be 6d equals to 49, which further can be written as, if we'll take 2 common from the bracket, we'll get 7 into 2 upon 2 into a plus 3d equals to 49. Here 2 and 2 will cancel, 7 will cancel, 49 7 times. We'll get a plus 3d equals to 7. That is equation number 1. Next, when we take S17, that is given 289, which will be equals to 17 upon 2 into 2a plus 17 minus 1, that is 16d, which is 289. So here we can cancel this 17 times, and if you take 2 common from 2a plus 16d, we'll get a plus 8d. So here we'll get this one as a plus 8d equals to 17, that is equation number 2. Now, solving first and second, what we'll get is subtracting 1 from 2, we'll get a and a cancelled, 8d minus 3d will be 5d, which will be 17 minus 7, that is 10, which means the value of d will be 2. And then if you substitute the value of d in any one of the equation, let's take from first, we'll get the value of a as 7 minus 3d, which will be 7 minus 3 into 2, 6, which is 1. So we got the value of a and d. Now we'll find sum of first n terms, that will be n by 2 into 2a plus n minus 1 into d, which will be n by 2 into 2 into 1 is 2 plus n minus 1 common difference is 2, which will be n by 2 into 2 plus 2n minus 2, here 2 and 2 will get cancelled, we'll get 2n square upon 2, which means it will be n square. So that is the sum of first n terms in this case. Moving to the next question, find the sum of first 40 positive integers divisible by 6. So here we have AP sequence, that is 6, 12, 18 and so on. For tiered term, it will be 240. So we have a equals to 6, d is also 6, n is equals to 40 and an equals to 240. If we'll take nth term formula as n by 2 into a plus an, we will get 40 upon 2 into 6 plus 240, which will be 20 into 246, which we can write it as 4920. The next question is, a contract on a construction job specifies a penalty for a delay of completion beyond a certain date as follows: rupees 200 for the first day, 250 for the second day, 300 for the third day, and so on. The penalty for each succeeding day being 50 rupees more than the preceding day, how much money the contractor has to pay as penalty, and also if he had delayed the work for 30 days. So here we'll try to find out what is the AP sequence. So in this case, the AP sequence as the first day fine is 200 rupees, so that will be the first term, and each succeeding day the fine is being increased by 50. So that means for next day it will be 250 rupees, following which it will be 300 and so on. It will go on till 30 days. Now here the value of A is 200, the value of D will be 50 and N will be equals to 30. We have to find out how much fine he will have to pay, that means S30. So here if you use SN term formula, which is n by 2 into 2a plus n minus 1 into d, it will be 30 upon 2 into 2 into 200 plus 30 minus 1 into common difference is 50, which we can write it as 15 into 400 plus 29 into 50, that will be 1450, which we can write it as 15 into 1850, and so on solving we'll get the value of it as 27,750 rupees. That means, therefore, contractor has to pay rupees 27,750 rupees. The next question is, in a school, a student thought of planting trees in and around the school to reduce the air pollution. It was decided that the number of trees that each section of each class will plant will be same as the class in which they are studying. A section of class 1 will plant 1 tree, a section of class 2 will plant 2 trees, and so on till class 12. There are 3 sections of each class. How many trees will be planted by the students? So here, first we'll try to form the AP sequence. So in this case, as it is given that class 1 will plant 1 tree, and as there are 3 sections, so total 3 trees will be planted by class 1, the students, following which class 2 will plant 2 trees, and again it is having 3 sections. So 6 trees will be planted by the class 2, following which class 3 will plant 9 trees, and so on. Class 12 will plant 12 into 3, 36 trees. Here, the first term will be A, that is 3. Common difference will be 6 minus 3, which is 3. N will be equals to 12. And here, nth term will also be here known, that is 36. Now, if you use Sn formula, which is n by 2 into, as we know the first term, last term and number of terms, will use a plus an, and n is given 12 upon 2, a value is 3 plus 36, which will be 6 into 39, which will be 234. The next question is, 200 logs are stacked in the following manner: 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. In how many rows are the 200 logs placed, and how many logs are there in the top row? So here, the AP sequence is 20, 19, 18, 17, and so on. The value of A will be 20. The D value is 19 minus 20, which is minus 1. And here we have to find out that N value, and also we have to find out what will be AN, whereas it is given that Sn equals to 200. If we use Sn formula, which is n by 2 into 2a plus n minus 1 into d, which is given as 200, we'll get n by 2 into 20 plus n minus 1, common difference is minus 1, which is 200. We'll get here n by 2 into 40 minus n plus 1 equals to 200, which is n by 2 into 41 minus n is 200. On multiplying, we'll get 41n minus n square, and 2 will multiply to 200. It will become 400. On writing in the standard form of quadratic, we'll get n square minus 41n plus 400 equals to 0. Now we'll use the splitting the middle term in order to factorize and find the value of n. So here, if you'll factorize 400, we can split it as 25 and 16, whose product is 400 and sum is 41. So it will be n square minus 25n minus 16n plus 400 equals to 0, which will be equals to n into n minus 25 minus 16 into n minus 25, which is 0, and which can be written as n minus 25 into n minus 16, which is equals to 0. Now, equating each factor to 0, we'll get n minus 25 equals to 0 or n minus 16 equals to 0, which will give n equals to 25 or n equals to 16. When n is 25, an, that is a25, will be a plus 24d, which will be a is 20 plus 24 into minus 1, which will be 20 minus 24, that is minus 4. It will get rejected, as the number of logs cannot be negative. Now we'll take when n equals to 16, we'll get a16 equals to a plus 15d, which will be 20 plus 15 into minus 1. On solving, we'll get the value of it as 5, which is possible. So we can say, therefore, n equals to 16 and an equals to 5. That means the number of rows will be 16 and the number of logs in the last row will be equals to 5. So the next question is, in a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato, and the other potatoes are placed 3 meters apart in a straight line. There are 10 potatoes in a line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drops it in the bucket, then again runs back to pick up the next potato, runs to the bucket to drop it in, and C continues in this same way until all the potatoes are in the bucket. What is the total distance the competitor has to run? So here the sequence of AP will be, to pick the first potato, C has to run 5 meters in one way, and then to keep it in the bucket, C has to return again 5 meters. So total distance traveled will be 10 meters. Then following which, to pick up the next potato, C will have to go 8 meters one way, and to return to the bucket, again C has to cover another 8 meters. That means C will have to cover total 16 meters. And this way, to pick up the third potato, again another 6 more meters will add up. So it will be 22, and this way it will continue. Now here, the first term is 10. Common difference will be 16 minus 10, which is 6. Here the number of potatoes will represent the number of terms, which is 10. We have to find out what is the total distance the competitor has to run. So we'll find out Sn, which is n by 2 into 2a plus n minus 1 into d, which is 10 upon 2 into 2a, that will be 2 into 10, 20, plus 10 minus 1, which will be 9, into common difference is 6, which will be 5 into 20 plus 54, that is 5 into 74, which will be equals to 370. And so therefore the competitor has to run 370 meters to put all the potatoes in the bucket. So this is all for this chapter as of now. Thank you. Take care, everyone.